Hey everyone, today is the 12th of December. This is Robot Builders Night Online virtual with Dallas Personal Robotics Group. We'll do the usual tonight, go around the table. We have a queue formed up already with Mike W, then Cooper, Ray, Pat, Tom, and then open mic. So I'll put this in the chat as a reminder, and if I sneak away for a moment or two, please do carry on without me. But Mike, what you got?
Yeah, well, I've been working on my robot. I like to do the mechanical first before I do the programming and the installation. But last time I showed it going in circles, but I had breadboards all over it, and I've added the go build a Odom pod, and I've put all the circuitry on the wire. So here's the current robot here. So you got to go build this here. I think I need a little bit more spring action, so I'm gonna have to design these to be a little longer so that I can pull the spring, get a little more tension. And now this side is, I put the Raspberry Pi with the screen on it too. And then this is the front one that does the X direction, and this one in the back does the Y direction, right? And then you can see here that I cleaned it up. I have a power supply module, and then this module here is the motor and encoder module. And the Pico here, the Raspberry Pi Pico is what manages all the motors and encoders. And so eventually I'll run a USB to the Raspberry Pi so it can read it and do something with it, hopefully in ROM. And I have a power supply connector here to power up the Raspberry Pi. So in here I have the, if I turn on the power, I have here's the 12 volt for the motors, and then 5 volt for the Raspberry Pi, and 5 volt for the other digital logic. So it's coming along. It doesn't do anything different. It still goes to the circle. I'm just trying to get the encoders understood so I can use them to calibrate the velocity. So that's where I'm at.
Mike, what are the specifications of the battery that you're going to use?
Huh? Pardon?
What battery are you going to use?
Oh, okay. On the bottom is the battery, and it's a so it's a battery that the professional camera equipment uses. It's a V-mount camera battery. And so this one has, it's 14 volts, 4.2 amp hours, so 60 watt hours, which is plenty for running this thing.
That's a nice, healthy battery.
It can put out, yeah, I needed weight. And because I built this with carbon fiber and printed materials. And so, right now it's a little over 4 pounds, which is relatively light. So I need a little heft for the odometry wheels and stuff to make good contact.
What top speed do you expect to be able to get from those gear motors and wheels?
I'm using the 20.4 low power 25V Polulu motors and an 80 millimeter wheel. I expect to get 1 meter per second.
That's pretty fast.
Yeah. So if you look at this again, like those motors don't take much current. So these little things here, see, where is it? Oh, huh. Oh, there it is. So, oh, trying to get it in the camera here. So these are the motor drivers here,
Right.
These little drivers, which are good enough for 1.5 amps, which is good enough for this motor. So it's a nice. So far, it's a pretty nice, clean design. And yeah, so I need to. I played around with ROS 2, just trying to do some examples and stuff. And so now I'm going to figure out how to get ROS 2 onto a Raspberry Pi in a clean way. And I think I'm hearing that Docker might be the best way to do that. So I'm sort of inclined to just put it onto natively, but so I'm sort of torn between the two. I'm sort of thinking just put the Raspberry Pi operating system and put Docker on there with Ubuntu and ROS 2 in a Docker. And that might be a really clean way to build it. Still trying to figure out what to do.
Which Raspberry Pi are you using?
4.
Which Raspberry Pi are you using? A 4?
Raspberry Pi 4B, I think.
Okay, so 4 gig of RAM?
I think so. Unless I went for, I have to go look and see which one I got. I got it a while back, and it might be underpowered, so I might have to upgrade it.
So for clarity, you're going to run Docker on the Pi, not on the host computer. Is that right?
Right. Well, the host computer would only be for debug. I mean, the host computer isn't part of the autonomous. So it'll run autonomously. So the Raspberry Pi is the main host computer, and the laptop would be a remote debug.
I was thinking about telemetry back. I mean, you're talking about the Magellan contest, right? Or you call it something different.
Robo Columbus.
Robo Columbus.
Yeah.
The outdoor one.
So you can, on that contest, you can receive telemetry, right? You can't actively control. Okay, right. That's what I was referring to.
So on my notebook, I can have a development computer receiving telemetry over Wi-Fi.
Yeah. Yeah, I've got a 4. That's what I'm working up towards. I'm just running ROS 2 directly off right under Ubuntu. I've seen other people talk about Docker on top of Ubuntu, but I don't know. It seemed pretty straightforward, just dropping it right on inside the Pi under the OS.
Yeah, that's where I'm heading right now. But oh well, so
you can always change it. It's
still, yeah, because I'm not overpowered right now, so that would be the most power efficient way to do it, at least CPU wise.
Yeah. Okay. I was just curious. I mean, I had seen other people talk about you running Docker, but I've always assumed it was on their base station to telemetry side, not on the Pi itself.
So it's a way to run Ubuntu and ROS on a Raspberry Pi operating system, which is a really good host on the Raspberry Pi. The native Raspberry Pi operating system, and to put a Docker image.
You'd run Raspbian, and under Raspbian you would run Docker Ubuntu, and then you'd load ROS 2 on that.
Right.
Oh, okay. Yeah, I just put Ubuntu directly on Pi.
Yeah, right now I have Ubuntu on Pi, and it's working. I'm trying to figure out how to put BNC on it, so I just have to work a little harder.
Okay, well, thanks.
Thanks. Oh, and Brendan, it seems like you know about this stuff. So on my notebook, I can run ROS and use it as the simulation and sort of the development system, remotely managing the ROS on the Raspberry Pi. Do you do that, or?
So I've got a PC. I'm running a virtual machine that's running Ubuntu 22.04.
Right.
And I'm running the same thing on the Pi. And I'm using ROS2 Humble. And the tricky part of the virtual is making sure you have your ports, bridged. I think it's bridged. Otherwise, it doesn't work very well.
Right. Yeah, that's putting it in a Docker image, I got to worry about that too on the Pi. So.
Yeah. I'm not as familiar with Docker. I played around with it some. I'm still kind of learning all of this, but that's what I currently have. And I got my virtual machine on my PC talking to the Raspberry 4B. This will be on the robot when I get it ready. But I'm actually talking. The two are talking right now, but the robot's not really in place yet. Right.
So I'm sort of going the other way. I got the machine and the mechanics done. Now I'm going to try to put the software on it. Yeah.
Right.
What are you trying to do with Docker? Is it basically just to try to lock down a config and separate the code and config from everything?
Okay.
I'm not sure.
Yeah. The idea is to be able to run Raspbian, which isn't compatible with ROS, and then have a Docker so you can actually run Ubuntu and ROS
right.
on top of Raspbian.
So rather than get the Raspberry Pi Ubuntu image, you want to do Raspbian and run Ubuntu on top of it.
It might be a good thing to do. I'm not sure, but right now I've loaded Ubuntu onto the Raspberry Pi, and I'm trying to get it up and running. That's probably the way I would do it because it's sort of the path of least resistance. Yeah, maybe.
Yeah, that's what I'm not there yet. I'm basically trying to do everything low level before I try to put layers with ROS and everything on top of that. But eventually, I'd like to do that. I'd be real interested to see how that goes for you.
Yeah, because right now I'm just running the Pico on the motor controller board, and it makes it run in a circle. Just something simple. Yeah. The next big milestone would be to have a game controller and a wireless game controller, and have the Raspberry Pi running ROS, interpret that, and control the motor.
Right. So you'd use like the teleop within ROS2 to do that, or?
Right.
Yeah. Okay.
Remote and be able to use a game controller or some kind of wireless controller to control the motors. And that's sort of my next big milestone. I guess the next milestone is get ROS running, but that's the big milestone is doing that. Yeah, thanks for all the feedback. I'm really pleased with my build so far. So
that looks real good.
Yeah, and this little pole on the top, it's extra tall, but I'm going to put the sensors on top of it. So I'll cut it to size and put the cameras and the LiDAR and stuff.
Okay.
That's why it says it. And it's also a really nice thing to hold on to. It's a good handle.
Okay. So I got a question. The way you're set up there, is the Raspberry Pi doing the motor control directly, or do you have something else running to control hardware, and the Raspberry Pi is controlling that? On that, at
this moment, the Pico processor is just running the motors in a static, going a circle mode, and then I'll have the Raspberry Pi interface to it, and I'll probably keep the interface just plain serial between the Pi and the Pico, the motor controller, and then put the ROS node inside of the Raspberry Pi. That would interface with the serial port.
So would you be doing like ROS serial on the Pico and then talking to the Raspberry Pi 4? Is that how you'd get your topics published and that sort of thing? Or
I'm thinking I'm just going to have just a plain serial interface to the motor controller, the Pico on the end, and then put all the fancy stuff inside the Raspberry Pi to interface it to a node, to make it a node that has all the fancy ROS stuff that, instead of trying to put micro ROS on the Raspberry Pi. It's still a toss-up, but I'm thinking that's the direction to go, is to not put micro ROS on the Pico.
Is it a Pico or Pico W?
Just a Pico. So it'll just I'll have a hard serial port, just a USB serial to connect to the Raspberry Pi. So everything should be nice and tight and timing real good. And inside the Pico, I'm going to do the motor velocity control. Because you'll give it a velocity command, and then it'll use the encoders to read the speed of the wheels and have a PID loop in there to make the motors go at the speed you want them inside the Pico. That should make it really nice and clean and tight and function well.
So, I guess I don't know ROS very well, but I thought that most of the output from ROS, like for the teleop, what it was outputting would be a velocity and an angle. So, how would that work?
I believe that's what you send the motor, and so that's what I'll send the motor on the over the serial port, and it'll just. But then I'll have a node wrapper that'll take the ROS message and just turn it into the serial ASCII characters.
Okay, so you'd just send the velocities over serial to the Pico without it having to know anything about ROS, and you do all the ROS interface stuff on the Pi 4. Is that how that would work?
That's what I think is a good thing to do. But I think that's going to work well.
Okay. Well, cool. I'd be real interested to see how that.
Me too. Me too.
I may be on the path behind you. I got to work on getting things to move myself first, but eventually.
Yeah. So it's going to take a while to get to the point where I can use a game controller to get this thing to move, but that's a big ROS thing that I'm not going to try to short circuit it and do the wireless game controller without ROS, which would be relatively easy to do. Yeah, maybe I'll do that, but who knows?
But you're designing this for the Robo Columbus competition, right?
Yeah.
That's what I thought.
Yeah. Last year's robot was really primitive and underpowered, and okay, I'm going to win this year. Yeah.
I have no doubt, Mike, the way that you're slamming these things together, you start from scratch, and the next thing you know, you have a robot that most of us would take about 2 or 3 years to lollygag around to. But you just knock it out in a few months, so we're enjoying your escapades.
Well, thank you.
Yeah.
Well, I'm done for my little show and tell. I'm happy with my wire management and my board. Hey, I'm good. I like my build. Yeah.
Cool.
All right.
That's awesome. I think next in queue, just as a reminder, I'll paste it, but we have Cooper. What do you have for us tonight, Cooper?
Well, I've got something with significantly less build quality. A realistic expectation, maybe, but I'm going for the gold star tonight.
Excellent.
Let me get set up here. So last week I presented a concept where I was trying to make a universal remote in some ways, where I could just build this thing, make it open source, document everything, and if I ever had to make another one, I could just use the same thing. You know, I could just, as long as I have, you know, a receiver and its respective controller, I could use that for any of the robots in the future. And a lot of the talk last time was about, you know, kind of the how to go about creating the interfaces for this sort of stuff, you know, making sure like you design or balance design expectations and all that. It's been a really busy week. I'm really glad to have just gotten this done. I have not gone back and taken notes on last week, but I will soon, so I'll have an update on that. But I just wanted to try and get back I have on a. Let's see. Sorry if my internet got really slow there. So this is a room that I kind of, you know, put a bunch of shit on. Oh, actually, sorry, excuse my language. A bunch of stuff on, and you know, it looks like a bomb, which is unfortunate, but it works, assuming, you know, everything doesn't fall apart on me. Essentially, I've just got, you know, some sort of Amazon battery, a you know, voltage regulator. On the battery, I've also got one of these little under voltage protection things where it basically beeps at me real loud if it detects that it's too low a power. I've got an ESP32 acting as my receiver. That's connected over serial to a Raspberry Pi Pico W. I'm not actually using the Wi-Fi on the Pico W. It's what I had. And that's connected to one of the, you know, the classic LN24 or LN298. You know what I'm talking about. You've seen them. And so, yeah, I had to duct tape a weight on there because, you know, how they get these things to make sure that they don't kind of tip over and keep going is that, you know, they've got these wheel modules and they've got little limit switches in there. So when you actually have it, you know, on the ground, it drives, and if it's not on the ground, then it doesn't. I don't have any of that hooked up. I just have the motors hooked up. So I've got that.
Is that a Roomba chassis?
Yeah, that's what I was saying earlier. I found a Roomba at Goodwill for, you know, $10, and I couldn't pass it up because, I mean, got a lot of good stuff in there. So, and I built this a while back. I was working on this as a separate project, and I never got around to finishing it, partially because I didn't have this remote receiver or remote control receiver thing done. So, yeah, I'm finally getting to that, and maybe eventually I'll get back to whatever this project was originally for. And so I can just plug in everything in any arbitrary order. That's one of the things is I want to make sure that this thing, you know, doesn't start going off towards Jones's if I plug in something in the wrong order. And so that's done through a combination. Well, in the future, it'll be done through detecting disconnects because the ESP32 has that automatically. But right now, it's just done by the simple fact that if I haven't sent any data over, then the value's 0 for the potentiometer reading, and it's practically never 0 in actual use. So I can pretty much rely on it. I've also got a dead zone set up on this, you know, little potentiometer here, or yeah, joystick. But you can see that this is all self-contained. It's a bundle of wires, but it's self-contained, and it's just the controller. Sorry, the controller ESP32 hooked up directly to one of these joysticks, and hopefully, with any luck.
Oh, cool.
And so this is using ESP Now, like I talked about last time. I had some really kind of tough time with surprisingly not ESP Now. What took me the longest trying to get from where I was last time to trying to get here was actually the serial connection between the ESP32 and the Raspberry Pi Pico W. And if any of y'all have any experience with that, it would be really greatly appreciated, because a lot, I was checking, a lot of the data that's sent in between gets rejected by the checksum that I've implemented. And it's like a kind of a concerning amount. So I think there's something programmatical to the way that I'm losing packets. Oh, the other diagnostic that was pretty, smoking gun was just that it only corrupted that serial data when it was actively transmitting and receiving data, or the remote was. So that's something. But for now, the checksum I'm using is just a 32 byte, 32-bit checksum? 32-bit checksum. No, it's 30, whatever. It's one of the larger checksum standards, and it works well enough for the packet size. And so, yeah, it's got a decent amount of power, just running off of a 3S LiPo. It actually kind of kicks its wheel out from under it, but yeah, so that's it. And then kind of the future plans is just, I've been staying on here. I'd like to make this robot chassis a little nicer so I can present more on it, but I'm mainly going to focus on the controller and receiver, and the next big couple of steps are I've got the infrastructure, so to speak, laid out to implement telemetry, which should hopefully be on the robot next time I present it to you. I really want, well, actually, in order to even do telemetry, I need to have a handshake, so to speak, where, and I understand that's a term that's already used, so I'm misusing it. I'll figure out a better term for it later. But basically something where the receiver can say, hey, I'm ready to transmit and receive data, and the controller says the same thing. And also, if one of them gets disconnected or unpowered and then repowered, it sends that handshake again and kind of, recycles everything such that it actually, everything falls into place all nice like. But it's required for telemetry because of the fact that these don't actually connect in the traditional manner through Wi-Fi. They use MAC addresses. And right now, the controller dynamically finds the MAC address of the receiver based on the fact that the receiver access point name is something specific. But from what I was reading, you can't really find the MAC address of a connected client, since this is the access point. So that handshake's required to basically have the controller send the MAC address to the receiver. But once I get that all set up, then telemetry's next, and then there's a couple other quality of life features that I'd like to add in terms of the code. And then once that's done, then I will go on to kind of design, iterate, and finalize what I'm going to have for the release, 1.0 version of this thing, and I'll make it public at that point. So that's it.
So you mentioned some communication issues. I don't know how you have your robot set up, but I've had problems in the past with my battery. Your power system, your electronics want clean power. Your motors wreaks havoc on your power system. If you don't isolate those two, you can get corruption on your communication on the electronic side. So I don't know if that's something you've already addressed, but it's a harder problem than you might think to separate those two. So just something to think about. If you think that your two controllers should be talking but they're not, it may be your power.
Thankfully, at least between the controller and the receiver ports, there's not really that much packet loss as far as I'm aware. I need to do more testing, And from the testing that I've done with everything on the robot and all that, I actually need to, if anybody else, that was the other thing, if anybody else has got a recommendation on ESP32 boards that have the external Wi-Fi antenna port, because this tends to lose connection as soon as something either pretty solid, like a human, or in this case, even the, dumbbell that's on here kind of gets in between the line of sight between the controller and receiver. But thankfully, yeah, there's not that much packet loss there. The real packet, or the real corruption, packet loss, whatever you want to call it, happens between the receiver and the kind of the robot CPU, as I called it last time, but just, the robot microprocessor, and that's serial. I agree with you that definitely the motors could be wreaking havoc, even more so than what I saw previously, though that corruption was happening on my test bed that didn't have any motors hooked up to it. It was literally just two microprocessors plugged in to my my PC there, and that could also have its own set of funk, so to speak, in terms of with the power that it's getting. So I'll definitely look at that. I have an oscilloscope, but it's not here, so that makes that a little bit harder to see the noise, so to speak. But I'll definitely look into that. Was there any suggestions on the ESP32 boards that have the external Wi-Fi antenna port?
I was just checking to see if mine has those ports. I thought I had one on there.
I have one, but it's like the ESP32 cam, and I don't know if I really want to use that. It just seems kind of not inappropriate, but it doesn't seem proper, I guess. I don't know. I saw some on Amazon, but they were pretty lackluster. They were, I don't know, they didn't seem to have a lot of development features that I would really like. And I understand that there are some out there that have like, a NeoPixel and, USB-C and this and that. All the ones on Amazon that I'm finding are pretty bare bones. I don't know.
Well, you know about Adafruit and those other places that you go to, right? To buy these.
Yeah.
But I'm pretty sure I bought them in the past. They have the little hardware external antenna that you have to decouple it, the internal, and I think there's a solder bridge that you have to break, and then you just pop in the little micro antenna connector.
All right. Yeah, I'll definitely look in it.
I would think that'd be a better, if you're looking for range, and that would be a better solution.
Definitely. I don't know about range. I heard kind of conflicting values for the range on this sort of thing, but I'm not really looking to have this be a long range thing. I just think that the antennas are going to help improve connectivity, just because, again, yeah, if anything gets between them, anything solid gets between them in their line of sight, they just kind of lose connection, and that's not optimal, so to speak. But so yeah, I don't know. I think that's just about the end of it.
Yeah, so I think I saw somebody use like a travel hotspot.
Travel router.
Yeah.
Yeah.
Where they were having problems with local networks, and that seemed to help a lot. And some of those are dirt cheap. That might be a solution as well.
Yeah. I was looking at that too. $39 right now on Amazon for a, I think it's 800 megabits. It's dual band, actually. Yeah, I'm looking at that also. I think it's a good solution.
Can you send that in chat by chance? I've been kind of looking at those, but I hadn't seen ones that were kind of robot friendly, so to speak. They were all, consumer grade ones that were big and bulky and
Oh no, this is a pocket. Yeah, I'll put the one I'm looking at in chat.
Yeah, the one I saw, there's like a little yellow box that was probably no bigger than your fist, maybe 3/4 of an inch or an inch thick, and like that. So it was laptop bag size for sure.
So I'll share a feedback on that because when I first started playing with this 5 or 8 years ago, I had a heavy reliance on Wi-Fi from the laptop to the robot, and at the time I thought, well, I'll just go for bandwidth and the latest whiz-bang specs. So I used one of these little. Yep. So try and grab it by the ultra-stable base there. And of course, MIMO, Asus, Black Knight router. It had N, dual band. And I found that it worked fine in my home. And as soon as I took it into the makerspace or the Fort Worth Museum of Science and History, and anybody showed up, like 3 people came with their phone, Wi-Fi or something, and next thing you know, the Wi-Fi just crapped out. It couldn't handle it. This guy just could not connect with the built-in Wi-Fi on the Raspberry Pi of the day. And what I found out the hard way was, I went to this super old, probably should be retired, but I think you can still find him, little TP-Link guy, right? Just runs off of 5-volt USB. And
is it a range extender?
Well, there's like there's one that it's meant to. It used to be for the days when you could go to the hotel, but they didn't have Wi-Fi, so you'd plug this into the wall for Ethernet and give yourself a hotspot rather than pay for Wi-Fi. So when I hear travel router, that's what I think. And I actually found that it was old school. It was B, maybe it was G. I don't know. Single band antenna, internal antenna, not this fancy 3 antenna. And it rocked. So there was this one time DPRG did a demo out at the Fort Worth Maker Fair, Science Museum there. And for 3 or 4 hours, I just struggled with this, right? I could get a nice long extension cord and follow the robot around. So it was 1 or 2 feet away, and it was better than it was when it was 6 or 12 feet away, but it still was terrible. Next thing I know, I finally said, what the hell? So I turned that off. I turned this guy on. And then all the way across the room, it ran for another 2 hours without it stopped once, lost the connection. So my lesson learned in all of that is that these fancier things, the higher bands, the super high bandwidth channels, they rely on a lot of things going right. And when you look at like good old fashioned 11 channel 802.11b. with its nice, wide, broad things, I think you can have little spurs and noise things in one frequency or another, and it's going to keep on cranking on. You're not going to transfer Blu-ray DVDs in seconds, but for telemetries, for the robot we do. Okay, so that's my lesson learned. It's one of the TP links. I'll see if I can figure out which one it is and put the link in here.
Yeah, I put the link of the travel one that I'm looking at, and it's real similar to what you have there, Carl, but it's probably a modern version.
Yeah.
It runs on battery or wall wart, but it's small and compact, fits in your pocket.
Yep. Well, again, my point is sometimes the newfangled standards can fight each other, and just downgrading to an old standard might do the trick.
Yeah, perfect. I'll definitely look into that. I am looking at if I do have a router of some sort, one of those travel-sized ones would actually be even better, at least for my use case, because the how the ESP now works, it actually wants the receiver to act as the access point, and so it would be better to have the router on the robot, and that way or in that way, a smaller one would be better. Though you said this one was battery powered. Does it have like a battery in it?
Not the one
No, it's got a USB-C port, so you can either use a battery to power it, or you can use a wall wart.
Okay, I see.
I don't think it has one in it. You might check. I was going to just power it off my system battery. Well, I haven't decided if I put it on base station, remote station, or on the robot itself. I'm still trying to figure. Well, I can try it both ways. That's what's nice about this. If you build it yourself, you can build it, try it. If you don't like it, you reconfigure it.
Yeah, 1,000,000%.
For your comment about ESP32 cams commonly having external antennas, but not many others, is very interesting. I've just been Googling it, and I've only found one other development board that actually has an external antenna. So I put the link in the chat for that particular one. But that might be the kind of thing you want to start looking for, depending on your preferred supplier. But the link is for AliExpress.
Oh, okay, yeah. I just tend to look on Amazon, and whatever is there, so, you know.
I'm cheap, so it's
I'm sure I could have sworn, though, I could have sworn that Adafruit had one that was one of their... No, it wasn't Adafruit. It was... have y'all seen the Zhao Sweet Seed Guino sort of stuff? They're these real small ESP development boards. I'll see. I'll hand off the presentation to the next person, and I'll do some research and try and throw those in chat. They were really, I was really impressed with them a couple of years ago. They had, I think, I don't even remember what what type of microprocessor it had, but it was just about the size of a quarter, and it had USB-C all the way back then. And I mean, they were like $20 for 3 of them. It was a really good deal at the time, and they seemed to kind of expand on that. And last time I looked, I mean, it was about a month ago, but I mean, they had some really cool stuff that just had different sets of use cases. So they had one for like, if you want to do Wi-Fi stuff, or if you just want like raw power from the ESP32. They had all different boards for that, and I think that's what I'm thinking of, because one of them did have that external antenna port. Now I'm thinking about it, so yeah, I'll look into that. But if there's no other comments, then I'll hand off the presentation, just because I've been on it for a while.
Yeah, I don't think this one does.
Yeah, you're talking about SciPede XAIO, I think is how it's spelled.
Yeah, I just thought that was pronounced Zhao, but maybe not.
I don't know.
Yeah.
But yeah, they did have several, and Adafruit had several. And there was a board that Seed Studio made that you could stick those on, and it actually had 2 pins, or 4 pins actually, I think, for debug, and those interfered with the Adafruit Cutie Pie, so I clipped them off. They were like pogo pins, or pins on springs, and it's so now I can really put either one on it, and I never really use the software debug anyway. So
yeah, that's fair enough. Yeah, actually, I just found them on DigiKey. I think the one I was thinking of, and this is one of those newer ESP32. I think the C3s, and it has that external antenna. It's only $4, so I'm definitely going to look at that.
Yeah, I put one from SparkFun. It looks real similar, and it's about $4 or $5 too. So it's just the MCU itself. It's not the larger board, but it's got an external antenna port on it.
How interesting. Huh. That could definitely be useful if I end up making my own custom PCBs for the receiver, and I guess also a controller, but I'll definitely look into that then too. That is really I didn't know they sold that. So, yeah, again, thank y'all so much for the feedback. I'm just happy to have something to present. So, and then hopefully next.
You know, what you could do is, you know, they have the USB wireless dongles that you could run up. And so if you basically just got one of the like cheapy low power USB hubs, like the 2 or 3 port ones, you could shove one of those in there and do it that way. You know, like the USB-C, run that to a hub, and then run whatever if you wanted to do wireless off board for whatever reason, yeah, then you could, like one solution would be something like that, where you have the ESP32, plugged in, going to a hub, and you could do whatever you want to, including, connect something bigger inside that hub and run serial to that directly. Like,
oh yeah, I didn't even think about that. Yeah.
So that would be, something like that, where you've got like the Nano Shield and the ESP32 going to a hub. That might be.
That's an interesting point. I never thought about using the USB port on an Arduino or similar and connecting those, I guess, to each other, and you could use that as a serial interface.
Yeah.
That would be really interesting. Yeah.
Yeah, you don't have to do it wirelessly, on board, especially. If you're on board, doing it wirelessly is kind of a waste, actually. When you've got a easy means to do direct connection that's more reliable. But I mean, if you're doing like remote host off your desktop or something like that to the robot, then obviously that's not going to work.
Yeah, I don't know. That's interesting. I got to think on that. I'm just trying to piece together how that would work. It makes total sense, though. I mean, really.
But you're right. I mean, the wireless is under that shielding. There's no external antenna directly on that dude. So anyway, that's what I was trying to answer. But
well, yeah, perfect. So as I was going to say earlier, thank y'all so much for the feedback, and I'll definitely have more to show next week. So.
Gold star this week. That's awesome. All right. Thank you, Cooper. So I think next we had Ray, then Pat, then Tom, then open mic.
Okay. Okay. I've been working on all things mechanical. So here is one of the outdoor chassis. This is Go Builda. And so I've got basically the frame pieces together, and I mounted my wheels that I've used on, the outdoor platforms. So this is, it's belt drive. So there's a belt on either channel here that, connects the 2 left side or 2 right side wheels together mechanically. And, I still have to put a piece in the middle to stick a mast on so I can mount the cameras and stuff on. So I don't have too much more to do mechanically. I can start working on the electrical stuff. And then, let's see here. For the indoor contest, I've been working on another platform. Just started doing this the other day. These are the
Did you get home medicine?
No.
Okay.
The 3-phase brushless. Darn it. Oh, there it goes. Can't see myself. Anyway, so these are 2 3-phase brushless motors with encoders on the back. So they have, quadrature encoder outputs and Hall sensor outputs, and mounted with Pololu hubs, and I think Pololu wheels. I think that's where they came from, and that's on a make block, the aluminum frame. So that's kind of the start of that. There's a lot more electronics that are required to drive the three-phase brushless motor.
Hey, Ray.
Yeah.
Can you hold that up again and maybe put a link to the motors?
Oh, I got these motors. Well, they're
said Robo
Elcom motors. They're yeah.
Do you know if they're available still?
I don't think so. I got them when I left Hitachi in 2003.
Ah, okay.
I think Elcon is still in business. I'd have to look it up though.
Well, this sucker's how fast are they?
These ones,
is there a gearbox in the front that I'm not seeing, or?
No, it's just direct drive. Wheel right on the motor. Pretty fast. I'm not certain what the max RPM was. I wrote it down. I tested them at one point, but I'd have to look it up in my notebook to find it again. But they may actually be too fast in this mode because I'm, three-phase brushless motors, you can spin up really pretty fast. Especially the smaller ones, several thousand RPMs. Which is, way too fast with a wheel that big on it. So I may have to gear it down to, get the speed and a range, but I was going to experiment it, just with like direct drive, wheel attached right to the motor if I can.
Interesting. Normally, you wouldn't do that, I would think, but let's see how it goes. Let me ask you this. I was intrigued by your, I'm kind of focused on my outdoor robot.
Yep.
So, can you show me how you mounted those wheels to, can you go through the axle mounts of the wheels on that big one? Because I'm a little I took Carl's advice and I got some I'm not messing with my other platform until I'm going to continue to use it for a base until I get all the other stuff done. And those things are with 10 millimeter belts. They really, really do well.
Yeah.
So let's see. But I would love to have bigger wheels, or I should say wider wheels.
Okay, what I did, I don't know if you can see it or not.
Okay.
But I had, there's a metal plate right here. It's kind of like a hub, basically.
Yeah.
And the the actual center of the wheel, there's nothing there. It's hollow.
Gotcha. I see what you're doing now.
So I actually mounted the Go Build a hub onto that plate. I had to, the hub is like, it's, the metric dimensions, I think it's 14 millimeters, which is very close to 9/16. Yeah. So I kind of did it, in a process where everything was like center locating. So on my lathe, I actually, I started out, drilled out a 1/2-inch hole on these plates, which are, they're actually 4-inch round electrical, box covers without the hole in the center. Because if you get the hole in the center, it screws up drilling it out and all that kind of stuff.
Yeah.
Okay, so I drilled a 1/2-inch hole in that. I actually had a drill bit that had a 1/2-inch shank with a 3/4-inch drill, and the hole in those wheels is 3/4 inch. So you know, I would center this in a 4-jaw chuck, drill a 1/2-inch hole. On my drill press, there's a center hole that, you know, a drill can pass through. And I made a plastic adapter that I forget what the size hole was. It was bigger than 3/4, I think. I think it was actually 1, and I reduced that down to 1/2 inch so I could, you know, and I actually drilled a 1/2-inch hole through a piece of plywood so I could push the drill through it. And so I had the wood and then this plate and the drill sticking on top. And then I could stick the wheel on top of that. And there are 3 places on those wheels. I'm assuming it was maybe like some sort of hubcap for a lawnmower, because they're old lawnmower wheels. And so that's how I actually drilled out the 3 holes, just kind of lining that up on my drill press.
Yeah.
Then I had to enlarge the hole to 9/16 or 14 millimeters. And I put down, held the Go Build-A-Hub onto the plate, which was, you know, centered on it now because of, you know, I had a 14 millimeter hole, and there's a little bit of a, not much. I mean, it's maybe 2 millimeters at most on the hub that stuck in the hole that kept it centered, and then drilled out the 4 holes, you know, kind of on either side of, you know, because it's got four legs on it. So, so it all worked out. They seem pretty centered. You know, I have to.
Okay, on the wheels, do you happen to have a 5th wheel around somewhere?
No, I don't.
Okay,
they're all on something now.
Because I bought some wheels and they look nice, but they're heavy. I think they're heavy, and I'm curious at how much those weighed. Were they less than a pound? More than a pound? More than 2 pounds?
I would say probably around 2 pounds.
Okay, that's about the same as these. So okay.
Yeah, per wheel.
Maybe that for that size wheel, that's what you got to have.
Yeah, it's got a fair amount of plastic in it.
Yeah. Okay.
They have Go Builder has 2 kits that run off kind of the same motors that they're showing. One's a 4-wheel drive.
Mm-hmm.
That might give you some ideas on how they're connecting those. It's if you look at the Recon chassis kit, I think it's got a mechanical drawing for that one.
Okay, well that's worth it too. What I'm really looking at, Brad, was that you know, mine is I think essentially a wheelbarrow replacement wheel,
right?
Or a cart wheel, or maybe a cart wheel. You know, for a wheel like a not a wheelbarrow. What do they call? Well, it probably could be a wheelbarrow cart wheel too. I don't know, but I'm thinking of some sort of cart with 4 wheels on it, and so it's plastic. It's heavy, and I want to say it's like 5/8 hole in the middle of it, and that I'd like to stay with something that's close to a metric size. So, you know, I favor 8 millimeters, and I guess, Ray, you're saying at 9/16 they come close together.
Yeah, 9/16 is about 14 millimeters, and you know that was just the whole.
Change. Yeah, just otherwise I want something that you know, if I'm buying stuff off the web, it's almost always metric. So it's nice to have a size that's close.
Yes. What I found, since I have, you know, a fair amount of make block stuff, that's based on 8 and 16 millimeter spacing, and that's what the Go Build-A stuff is. So I can actually use make block stuff on a Go Build-A platform if I wanted to. Yeah. So, but Go Build-A has, you know, a pretty wide variety of things that they offer. So, And I wanted a certain width for the wheels and a certain spacing between the left and right side of the two sets of wheels. So that's kind of why I went with the individual components, not a pre-made kit, because.
Well, I like to find stuff and put it together like you do too, Ray. So
yeah. So
I'm not a.
Plus, it costs $300, and I did it for a little bit less than $300. So.
Yeah. That's
But anyway, these are the 3-phase brushless motor drivers, and so I got to have one for each wheel, basically.
Yeah.
So I'll use, and I have the other platform that I've been working on. With the, what are those things called? Hoverboard motors on it. So I can use 2 of these on the indoor platform and 2 of them on the outdoor platform that both have different 3-phase brushless motors on them. So anyway,
so that you have like a common motor on each side? Is it one motor drives both wheels on each side? So
they're connected by a cog belt or whatever you want to call it. I think Go Builder recommended the heavier duty belts for not like a GT2 belt. I want to say it's a 3mm belt. Or 5mm? No, I think it's a 5mm.
And you guys are giving me Project Envy so bad.
That's the trouble with this call. It hits all of us, but it's nice. It's good motivation. Yeah.
Yeah, they're the 5mm HTD belts. So for, they recommend it for larger scale chassis that are driven by higher torque motors, and these are the the Saturn motors, which are the higher torque motors that I chose. So they have a planetary gear head on it and reduction head.
Well, I'm still in my quest for the perfect 10-inch light, wide wheel. I haven't got it yet, but I do have some 10-inch wheels. We'll see how they go. But
I'm actually getting 2 replacement wheels. I could weigh one when when they come in. I actually took.
That'd be good. I would appreciate that. I would appreciate that, Ray, because like I say, I'm looking for anything. I want to figure out how to get something. The problem with the ones that you're using and the ones that I've got, both of them are rigid plastic wheels. So, suspension-wise, they suck. And actually in traction, they're not really super good either. The ones that kind of that are soft, like what Scott's got on his burp. No, that's not burp, whatever it is, belch. What he has on belch is going to be, it hugs the ground better.
Yeah, they're flexible. I'm sure he could probably bounce it around without it.
And they're light. They're considerably lighter than our 2 pounds. So somehow he's. And they also, I remember at the time, I think he said $50 to $100 a piece, and now you can't buy them. So mine were 2 for $20.
Wheels.
Yeah, mine were 2 for $20, so it's a little different. Ball range.
Okay. Yeah, I got mine at Surplus Center. I think they were either $2 or $3 each.
Yeah, cool.
They're really cheap.
Yeah.
Actually, I think they do weigh probably less than a pound.
Okay. Well, if you do you have their link by any chance?
I can look at it real quick here.
Okay.
It may say what the weight is.
I was watching this show and somebody had a nitinol slinky wrapped around a hub for a wheel. That was the Slinky was their suspension. It was actually a JPL or NASA show that they were using nitinol.
A Slinky.
Yeah, it was just a Slinky.
What's the weight?
Total
weight.
But it heats up and it gets its shape back. So.
Actually, this says shipping 3 pounds.
For one wheel?
1 wheel, yeah.
So they're probably about 2 pounds, I would imagine. Okay, well, we'll see.
Yep. Yeah, and they're $3.95 each.
Yeah. Throw the link in. Throw the link in.
Okay. Oops. Copy.
Now, I'm curious. Did you go for brushless for efficiency? Is that what that was the motor you had?
I went for the buy 3-phase motors for the least amount that I could. So I went to my local thrift store and bought it. Actually found 2 hoverboards. This is kind of the shell of one of them that I took the motors off of, and that's its battery. And I mounted them on a piece of plastic that I had. So I think, I don't know if the price is still written on it or not. One of them was like $8 or $9, I think. Or no, maybe, I don't know.
Are on those hoverboards are both sides driven?
Yeah, they're 2 separate motors. But yeah, I guess I've rubbed the price off. I don't know what it is anymore. It's partially there, but I can't really read it. But they were pretty cheap. And there's another one here. Okay, this one was $8.99. There's another one. That and it basically took the the wheels off and mounted them to another plate. As any of the other internals, I'm not really using it. So,
are you using the ESC from that? Oh no, you went and got a different ESC.
What's that?
I said, are you using the ESC that's built into that, or a separate or a different?
Yeah, no, it.
Said you were using different.
The actual mechanism that they use, they have like a some sort of inertial measurement unit, because you control the thing by tilting, one side or the other, forward or backward, to get the wheel to, the more you tilt it down, the faster it moves, and that's where you fall off at that point. So but no, I didn't use the internal boards, and it was much easier to use these little controllers that for each one. You just put in a PWM and it does the regulation for you. I don't know, I'm sure there's limits to how fast I can, input or increase the PWM signal. I don't know if I can go from nothing to, 100% PWM, or, 255 out of 255, and still have the thing keep up with it. It's difficult to say how quickly the combination of motor and driver will respond. I know, the 3-phase motors can draw a lot of current when they, when you do that, when you, just hit it that hard. So, really, it probably depends on, what my batteries can actually source and all that.
It's not that hard to write either. I mean, especially if you're on like a 20 hertz loop, you can, add, some offset of speed until you get to your whatever your desired speed is. Slewing's not.
Yeah, Yeah. And this actually has a speed output on it. So
Ray, on your other one, you're just going to use brushed motors, right? The
brushed,
the outdoor one. You're not using.
Yep.
Well, brushless should be more efficient.
Yeah. Well, okay. On the 4-wheel drive one, those are brushless. On the scooter one, which is the 3-phase motors, that's another outdoor platform that I've been playing with. So I want to try. I don't know if I'm spreading myself too thin, but
yeah. Ray, you confused me on those chassis with the gold build structural elements.
Yeah.
What those motors are 3-phase? Or
no, those are not 3-phase. Those are
just brush motor.
Brushed.
Yeah.
But okay. The other platform that I want to make is with the hoverboard motors, which are 3-phase, brushless.
Mm-hmm. That's the one you showed us, the front part of it or the back part of it, depending on what. The one that has the 2 hooked up on it.
Yeah, the 2 wheels on it right now. It's just these 2. That's as far as I've gotten, and I've got a.
Oh, are you going to make it a different? Are you going to make it a 2-wheel robot with a? Yeah. You're going. Yeah. So you're going to go back to using a caster.
Yeah, in the back, but I'm actually going to put the other plate on this perpendicular, so it's much higher than the wheels, so I can get a larger caster back there. I think I can fit a 6-inch caster instead of before I had a 3-inch, which was a little too small. So, oops, kicking stuff around. Anyway,
that's cool stuff.
More things that I can probably do in a year's time, but I'm going to try it anyway. So,
I'd like to hear how that brushless controller you have. I've been thinking about, outdoor since I've been watching you guys and looking at the different options, and I was looking at scooter hub motors which are going to require a brushless.
Yeah, these were pretty cheap. Got them on AliExpress. I think they were like $7.95 each or something, and they'll do. Now let's see if I can find them. Oh, whoops! I'm already there. Okay, yeah.
I gotta stay on task. I can't be thinking about the next project. It's hard.
Good luck with that.
So many projects, so little time.
No.
This is why I haven't built one that actually works very well in 20 plus years.
Boom, come on. Okay. Waters, yeah, it was this one here. $7.59. So 6 to 60 volts, 400 watts, supposedly.
Put the link in.
Okay.
Holy crap, that's cheap.
So they give you a cable for the Hall effect sensors, and that plugs in here, and here you actually get a pulse output, which is, I guess I consider it the overlapping of the 3 phases, or the signals from the Hall effect sensors. So it's 48 pulses per revolution is what you get out, or 96 edges rising and falling.
So you could use that instead of encoders, but you get fewer counts per revolution. I guess.
Yeah, you only get, 48 pulses total, or 96 edges. So
Cool.
but for that price, they seem to do pretty good. It's got a pretty good size heat sink on it, for there's 6 power transistors there that are FETs. I'm not certain what they are. That sits over, and they didn't seem to be any issues. I can spin them up and try to grab the motor, and it's kind of hard to hold on to with your fingers start smoking after a while. So, but okay, I'll put the link in that one. List. Well, I think that's a link to my. Let me find it another way. Okay, I can stick it in a minute. But yeah, they're pretty cheap. The things, the hoverboards were less than $10. I've only found 2. I haven't found another one. I'm kind of hoping that after Christmas, the parents got the kid a hoverboard and he wore the battery out or didn't charge it enough, and now it's showing up at the Goodwill again.
Go raid the TSA dumpster.
Say that again.
Go to the airport and raid the TSA dumpster.
Oh, why do they have a lot of those that they don't let on the planes or something?
Yeah, right.
No. Okay.
They had this history of flaming, bursting into flames. Yeah.
Oh, they did. Ooh, man.
Yeah.
But
that's not going to happen with your robot, Ray. No.
No, let's hope not. Yeah.
Yeah, Austin has this nice collection of brushless scooters that regularly get thrown into the weeds around Town Lake. So there's a ready supply of brushless motors down here.
Oh, really? Yeah. There was somebody in Dallas. They found it was like a box of the GPS sensors for scooters. So somebody took a lot of scooters and tore them all apart and threw the parts that they they didn't want tracking or to be tracked, I guess, with the pieces. So
yeah.
But I don't know if anybody else remembers that. He showed up at the makerspace and had this box of gutted parts, basically, that were somebody stole a lot of scooters, I think.
Yeah. Cool.
Yeah. Did Austin, say no more scooters for a while? And I know Dallas, you can have them again, but.
Yeah, I don't know. I try to stay out of Austin as much as I can. I'm actually just north of there in Georgetown.
Oh, okay.
So I used to live there, and back when it was, live and let live, and a lot smaller, and I can't stand going through Austin anymore.
Oh, yeah.
So,
yeah, I used to call on Dell a lot. So.
Yep, that's my customer. Yeah.
Oh, okay. Yeah, I used to, in the morning, if I couldn't make the Southwest flight, there was an American flight there for a while that was like a half hour later. And so I could still get there on time to, make meetings and pick up a rental car and all that stuff. And, but, sometimes just couldn't get, either traffic or something, couldn't make the Southwest flight. So.
Yep. Yep.
Oh, and then on the, it seemed like especially at Fridays in the summertime, all the flights, people wanted to get out of Austin, so if you had an open ticket, you just, you go from gate to gate to gate, hoping that, to get on the wait list. And it's like, okay, I just want to get home. This is getting ridiculous.
I used to do that 3 days a week. back in the
Oh, you did? Wow.
Yeah, when I joined DPRG, I lived up there, and that's what I was doing every day. Austin.
Oh, wow.
Yeah.
Yeah. Got a lot of Southwest miles. Then, that was a good thing. So.
Yeah, if I could stand to fly anymore, but yeah, that's the other problem.
Anyway, that's all I had.
All right, Ray. Very cool. Next in queue, we had Pat, then Tom, then open mic. So, Pat, you still with us?
I am so.
Excellent.
So I don't know if you guys remember this guy.
Wow.
CanBot.
CanBot.
Yeah.
It's got a Raspberry Pi, got an Arduino, got a motor driver, some of the yellow TT motors with encoders on them. So I'm working on this guy since I missed the other contest. So I decided to go work instead. I am working on an issue I have, and I'm going to share my screen. So can everybody see this guy?
Oh, yeah.
Yes.
Yes.
So that's the motor driver I have on top of an Arduino. And the problem that I have right now is that the motor driver pulse width modulation is coming off of pin 10 and pin 11. And when I look at pin 10 and pin 11 to try to increase the frequency of the pulse width modulation, I can come up with basically to try to get as close as I can to 20 kilohertz pulse width modulation to drive the motors. The best I can come up with on pin 9 and 10 is 7.8 kilohertz. And then on pin 9 and 10, I can come up with that's 10 bit, sorry, pin 3 and 11. So I'm looking at pin 10 and pin 11, and I can come up with 8 kilohertz. So the two pulse width modulations to drive my motors would not be matched to try to get the same speed or the same pulse width modulation going to each motor.
Okay.
To add to that, as well as a problem, is this guy uses for the servo pin, which is right up here in the corner, uses pin 9 for the pulse width modulation. And so that sort of excludes using that guy as a servo while using the motor as well on 9 and 10.
Yeah,
if I change the frequency. So I don't know if anybody knows of a way to do this. Otherwise, my next option is, I believe, is going to an Uno R4. With the Uno R4, I have a lot more flexibility with the timers and the pulse width modulations.
Mm-hmm.
And so that's where I'm thinking about switching the Uno board to an Uno R4 Minima. It's still 5 volt compatible, but I would gain the ability to drive both the pin 10 and pin 11 at 20 kilohertz, and then still be able to drive the servo at, let's say, 50 hertz.
Pat, yeah, I'm curious to know why you want to run the pulse width modulation frequency to the motors that fast.
Well, it doesn't have to be 20 kilohertz, but it definitely needs to be more than the base frequency on an Arduino, which is 490 hertz.
Yes, that's the base frequency. Why do you think it has to be faster?
Faster the better is what I'm told if you're driving a DC motor.
Yeah, I have some reference material that I'll post. It depends upon what characteristics you're trying to get out of the control of the motor. Generally speaking, 20 kilohertz is way too fast for small motors, especially those LTTs.
So I thought so as well when I saw it, but it was what I had read was saying go as fast as you could go for any DC motor you're trying to drive. I was thinking in the 5 kilohertz range should be plenty for a small motor.
Well, I would say this, Pat. There's a lot of very successful small robots being run off Arduinos, and they're not anywhere near 20 kilohertz. Okay, so I know that you may have been influenced partially by what Scott Gibson says. He runs his up there in that range. But if you look at his motors, they're hellishly different than a yellow TT motor. Okay?
100% understandable.
Okay, so what I'm saying is I think you do have some problems. You know, I just for simplicity and, you know, to make things work, you know, you've pointed out 2 problems with that board. Is there any way to reroute it or to at least get...
Well, I have rerouted 1 pin already because 1 pin was using D3, digital input 3, and I needed that pin to run an interrupt.
Yeah.
For an encoder.
What were they using? What pin were they using?
They were using D3 for an interrupt as one of the direction pins on the motor.
Okay. All right. Is it an Uno format or is it a Mega format?
It's an Uno format.
Yeah, I'll have to find my Uno board. Here's it now. All right. So
and I don't have room to put a Mega in there.
No, that's I'm just trying to figure out what pins are what. It's been a while since I looked at that. So they were using pin 3, which is INT1. Okay,
yes.
External interrupt 1. Okay. And what were you said they're... Okay, so you wanted to use 3. Okay.
I needed 3 for an interrupt, for an external interrupt.
Okay.
But I also needed D9 for the servo control because it goes there. Yeah. And then I needed D10 and D11 for the motor pulse width modulation.
Mm-hmm.
So they've sort of mixed up all the timers when they developed this board. Yeah, I don't know why.
It sounds like a problem because you somehow you need to get, I agree with you. You want both of your motors to come off the same timer.
Yes.
And so the question is, so you're using 9, 10, and 11. Well, you know, obviously 10 and 11 are what you should be using for your motors, and 9 is what you should be using for your servo if you had to be to those 3. Where are the other ones? Where's the other ones? Let's see.
So ideally 9 and 10 would be the ones go driving the motors, and then be able to use 11 for a servo.
Oh, okay. See, I'm so used to using a Mega where you all have a lot of alternative timers to screw with.
Lots of pins.
Yeah. Okay, so... Yeah, so you kind of need to reroute that. 10 and 11 to your motors and 9 to the thing.
So that's why I'm looking at an R4 minima because there's a lot more flexibility with the timers.
Well, that would be really cool to see. I think you'd be the first person I know in the club who's got an R4, and that would
I have
be
2 of them now.
Oh, do you already got one?
I already got 2.
Oh wow.
Never buy just one.
Yeah, no, I agree. Well, that sounds like a solution too. Is this an old? Is it? No, go ahead.
Yeah, so that was my solution, is to try to do that, as well as I'm trying to with this one offload some of the Raspberry Pi computations and do everything in the Arduino. So the more memory and a faster speed may help with that as well. But I don't know if how well I'll get there.
Yeah, I wouldn't worry about trying to set. When you get your motorboard on top of your R4, you know, just play around with that. And because I would believe for those small motors, I agree with. I'm sorry, I don't remember who said it. Tom. Yeah, you want to be towards. You don't want to be at 300 hertz. But you know, one of the intermediate ones is fine. You're looking at two things that you want to look at. One is, where does the motor start to turn? Okay, that's going to vary depending on the PWM. And the second thing is the linearity of the PWM. So, like if you're at 50 on PWM, is the motor going 50% of the speed? Okay, so you're going to have some sort of offset down at 0, and then you depending on which frequency you use, it'll become linear or non-linear. But those are the two things that you really want to look at. In the ideal world, the response of the motor speed would be directly proportional to your PWM percentage. Okay, it won't be perfect, but the more perfect you are, the better it would be. And then, like I say, there's just going to be some sort of offset at the bottom. And if you get the PWM frequency selection wrong, that'll be excessive. You may have to be at 30 PWM before it even starts to move. Do you know what I'm saying? So that's the problem I'm having presently with it. Yeah, because you end up with this big dead space in the middle.
And I keep overshooting when I make a turn to try to change to a direction. I keep overshooting one way and then overshooting on the way back, and it was not working it out at all.
Okay. Yeah. One thing there's a couple of ideas. I don't know if I've usually haven't had this, when I see this, I make adjustments, and so I don't have that big a problem. But the one thought is you can essentially eliminate your dead space, by saying, okay, if I'm down at 30 PWM, I'm switching directions. That's another thing. Did you look at that article I put out on the site about the 3 ways you can drive a motor? I don't know.
Trying to remember.
You might want to take a look at that and play with that. Again, I wrote that a while back, so I can't really remember. But there are pin benefits of writing it in different ways, and there's also motor response advantages there too. I'll see if I can find it real quick. But go ahead. I'm sorry, I interrupted.
No, that was about it. So my frustration with that little board has been the 3 different timers that are, in my opinion, just a bad design.
Yeah.
It should have been like D9 and D10. Should have been driven by the same timer for pulse width modulation of the wheels, freeing up being able to drive a servo with another timer.
Yeah, I agree with you. I think that's. Here it is.
But the size constraints for the fitting it under there, you can see that board, that little robot it's jam packed. So there's not much room right now anywhere except the top where some sensors are going to add stuff.
Okay, I'm putting that link in. You might take a look at this too.
I put in a couple of article links that I found useful a few years ago when I was dealing with this same problem. There are several others that I'll have to look for. They're part of a presentation I did a few years ago for another club, but I can't find it right now on my computer.
Thanks for that, Tom.
Yep. Yeah. You may find them useful. The testing they do in particular is with those two motors you're using.
Okay. They're very similar to those motors, except they have an encoder added on.
Yeah, same motor. I've got a bunch of them.
Okay.
Mm-hmm. Yeah, so take a look at that too when you get a chance.
Okay, great.
Yeah.
Yeah, that deals with that timer chip or a version of it. Is it L298N? I don't know what the difference between the 298N and the 298P is, but
yeah, the modes don't really matter. It's just that I picked that because it's so common.
Yep.
You know.
Yeah, if you did say, you know, one out of 256 for your duty cycle, and then, you know, figured out you're running at 490 hertz. That's like just under 8 microseconds. And the L298 was never a very fast device. I mean, some of the, let's see, like some of the switching times, current sync turn-off delay, the 0.7 of a microsecond. So, you know, it's a very slow part. Source current turn-off delay, 1.5 microseconds. So you're, you know, I guess if you're running it at in comparison to 490 hertz to 20 kilohertz, probably at 20 kilohertz it's going to be a little warmer, you know, because it's you're fighting all those
it's switching a lot. I figured I had to be somewhere above 490 because my deadband was just way too big. But like you say, 20 kilohertz I can understand on a larger motor.
Yeah.
Even some of the stuff we use in industry, we're switching 3-phase motors, but we're switching at 5 kilohertz.
Yeah.
So.
Yeah, I guess like I'm guessing the bigger the motor, the more inertia, you know, that rotor's going to have. So, you know, mechanically.
A little bit bigger than the yellow TT motors.
Yeah.
Yeah, well, I just did some experiments while you were playing, and the Pico can run at like 50 kilohertz PWM, but the motors don't quite run as fast. There are some inefficiencies there, and then the driver was getting a little warmer.
Oh yeah,
yeah.
Example, I had 20 kilohertz, but I think 5 kilohertz is a good one. Like at below 5 kilohertz, you start to hear the audible noise.
Yeah, but that's I was thinking when originally I looked at it is to try to get into the couple kilohertz range, between 1 and 2 kilohertz, and I can put up with a little bit of whining. It's not an issue as long as I can have better motor performance at the low speed end.
Yeah, and Mike, only some of us can hear it at 5 megahertz. I mean 5 kilohertz.
I can't hear it at 5, but I can hear it at 1. So.
Yeah.
That's it for me. That's been the dilemma. I haven't watched the recordings from the Robo Columbus. I'm looking forward to seeing that. Although I did hear that Ray got in first place right after Scott.
No, but I will say this: Carl finished loading up the run videos, and I've got them all organized on the website. So you can go to the post that's about Robo Columbus and look at all the runs now. And like I say, sometimes looking at those runs, you can learn things that you might miss. So anyway,
I quite enjoyed those. I appreciate you putting those up there, and congratulations to everybody for doing that. I was very impressed.
I was sorry I missed it this year. I was supposed to be in Dallas on the 18th of November, and instead I was in Birmingham on the 13th. I was in Houston on the 13th. Drove through Texas, or flew through Texas anyway.
Yeah.
So that's it for me. Thanks, guys.
Cool. You got it, Pat. All right. So based on the earlier sort of meeting, we have next Tom, and then open mic. Would anyone like to jump in queue after Tom? Not so far as we know. So Tom, you can lead us to open mic night.
All right. I probably have mentioned that a few months ago, a friend of mine in the Vancouver Club, who lives in Vancouver, has been working on a multi-year project for basically a small submarine, remotely operated vehicle. He's at the point where he has done some underwater testing, and that's where it became clear that once the thing gets deep enough where he can't see it from the surface, he doesn't know which way it's pointed anymore. So he thought a compass would be a useful thing to have, especially a digital compass. But Ian's background is, let's say, computers and fancy sensors and programming are things that are very, very new to him. So he asked for some help. And because I've done digital compasses before, I volunteered. The other interesting thing is we're 3,000 miles apart. And this is an educational exercise as well as attempting to help him build a compass. So we have built matching test environments to test this stuff with as just about as identical as possible. I'm just going to hold that up to my camera and see if you can see it. Basically, a couple of Arduinos with some interfacing stuff. The compass module is sitting right there on the end of that mast. The reason it's on a mast is because I've been testing it on a steel-framed desk, and I get much easier calibration if I keep it away from the steel of the desktop. So we're now at the point where we have the two Arduino modules working well, and we're in the process of joining them together. One of them will reside on the submarine, and it controls the compass and gathers data from the compass. It then sends that data over an RS-485 link over the tether that he uses to control his robot, which is about 100 feet long. And there will be a topside Arduino that simply drives a display with some information on it. So that's the exercise, the project we're using, and we're developing this thing in lockstep so that as I put together things and get them working, then I send them 3,000 miles away and he goes through the same exercise, a step at a time. We're at the point now, and this is where I'm not sure if this will be visible on my camera or not. You probably can't see the display at all. No, it's just, looks like it's just white. I'm going to share a small video I have here, which I sent him today. Just give me a second here to present this. Let's find out where it is. Too many things on my desktop, of course.
And you're certain his client's not a cartel because, you know, that's who wants submarines these days.
It's actually a nifty project. It's been a multi-year project for him.
It sounds cool.
Why can't I see?
Well, Ukraine's in the market too.
Yeah.
Oh, they are? Oh,
yeah, Crimea.
There it is right there. Let's try that.
Well, they may have sunk all those boats in the Crimea already.
Well, let's see what happens if I share that window. No, that's not of any use. I have this thing sitting here running in VLC. So all I have to do is open the VLC window, right? There it is, right there. All right, can you see that window? Let me drag it a little higher.
Oh, topside display.
Can you see that? It says topside display.
Yeah.
So what you're looking at is the display driven by the topside device, and it is connected over a serial interface on my workbench to the other Arduino, which has the compass on it. And what I'm going to do is start this video, and that'll give you a feeling for what happens. Topside display is simply what shows up as the splash screen when you initially reset the topside Arduino. I'll play this now and stop it when you're bored enough. What I'm doing is I'm simply rotating the compass in order to get some feeling for what the display will look like. Ian is satisfied with the equivalent of an 8-point compass rose display, which is what the alpha characters at the end of the top line are displaying. So basically translating the degree compass reading into north or south or east or west and so forth. My apologies for the shaky display. I'm holding my phone camera in one hand and rotating the compass in the other hand. But it turned out fairly well. The second row of characters is simply some dummy data. Ian has only asked for compass displays. Let me put this away now. Ian's only asked for compass displays, and that's what we have working at this point. But one of the interesting things is now that you have a computer on board the submarine, you can use it to collect all kinds of other interesting things. So I've suggested a few other things I think he might be interested in, such as the battery voltage on board the submarine and the tilt angles, that is the pitch and the roll associated with the submarine. Now, the compass will be not tilt compensated. After some discussions, Ian's pretty sure that because of the way his submarine is ballasted, he says it does very little tilting. And that means that the compass readings, as far as an 8-point compass resolution is concerned, the compass will be accurate enough, even though magnetic compasses, when you move them out of a level plane, begin to show errors because of the tilt, unless you compensate for them. So he's quite happy with it the way we've designed it and built it so far. Although I'm thinking I will, because I have lots of 6th degree of freedom IMUs kicking around here, I'm going to add one to this to the submarine component, and that will provide us with pitch and roll information, and also the information required to perform tilt compensation on the compass. So I'm quite interested to know how that will turn out, even if it's just to satisfy my own curiosity. So it's turned out to be quite an interesting project. The hard part has yet to come. When I get this to the point where he and I are happy with the results, then I ship all this stuff to him. Well, I email the code to him, and he implements it on his version of our test environment. When he's happy with that, of course, he has to mount it in the submarine. I don't have to do that part. But he's got lots of experience at making electronics work on board his sub. So we'll see how that works out when he actually has the sub providing him with compass information. I'm looking forward to that. That's about it. Questions?
This was tethered, or is he using RF?
Yeah. Well, RF doesn't work through the water, so it is tethered, and there is no autonomy in the submarine at all. It is strictly a remotely controlled, remotely piloted ROV. It contains cameras and lights, and it has a claw on it, a remotely controlled claw, because that's one of the objectives of his project, was to be able to move it around the bottom of various lakes and ponds and be able to grab stuff and retrieve stuff. So think of it as an interesting, sort of the kind of thing you do if you have a metal detector above ground. You can kind of wander around with this thing on the bottom of harbors and bays and see what you can find and bring up. And he has all of that working at this point. He was just quite surprised to realize that as soon as he loses sight of it, he has no idea where it's going.
Yeah, so I assume a metal shell, it's some kind of a fiber composite shell? Because
I beg your pardon?
The magnometer wouldn't work inside of a metal shell.
Sorry, you have to say that
what's
again?
the shell made out of?
Well,
body.
His ROV is a PVC tube frame with waterproof containers on it in order to hold the electronics and the battery. And it contains modified boat bilge pumps for purposes of propulsion. because those are very commonly used in this class of device. It's probably about a 2 or a 2.5 foot cube made out of PVC framing, skids on the bottom, an arm on the front, ballasted to make sure it stays upright. And he's got it ballasted, I think, fairly heavily in order to ensure he gets neutral buoyancy and to ensure that the thing is not going to turn upside down on him in use.
So those motors are going to really throw the calibration for a loop if they doesn't have soft and hard iron correction.
That is going to be another step we go through. He's comfortable with the idea that he may have to mount the compass module on a mast, which is fairly commonly done with robots as well. We'll have to experiment with that, but he's prepared to do that. The practical experience many people have with these things in boats and other motorized vehicles has been very helpful. I was amazed to find out that even batteries themselves have varying magnetic fields associated with them, which I wasn't aware of. I thought you just have to worry about currents and motors and magnets, but the batteries themselves can be a problem.
Yeah, I guess if you have charge moving through wires, you've got a magnetic field around the wire. So
yeah, just if you're using replaceable batteries, even changing the battery will change the nature of the soft and iron magnetic interferences. Right. So that's part of the reason why I'm happy that we can get away with without tilt compensation, because that means that the recalibration procedure for the magnetic compass can be done in 2 dimensions only. It does not require 3-dimensional calibration, which once you put this thing into his 30 or 40 pound submarine, gets a little bit cumbersome to do a 3D calibration, according to the classic methods for doing it. 2D is easy.
Yeah, it makes sense. A LiPo through a lot of current from a LiPo through a wire, that's a heck of a B field. So, I mean, it's generating a pretty good magnetic field around that conductor.
The research I've been reading on it actually indicates that the magnetic environment or the iron environment will vary even when you're not drawing currents through the battery.
Really?
Yeah, that's the part that surprised me. I didn't think that would happen. That when you're not drawing current, you'll still see differences when you change the batteries. So,
well, the polymer plates are metallized, aren't they? Is that what is?
I have no idea. So I'm not even sure what batteries he's got that he's using inside the thing. He may be using sealed lead acid, for example.
Yeah. Interesting.
It's quite the project. He's been like I said, this is a multi-year project for Ian. He's been working on it for quite a while and has had some interesting successes. But of course, as you very well know, the robot on your workbench is a whole lot different than the robot out in the field, and he's had the same experience with a ROV. Up on the pier, it works great. 20 feet below the surface, it doesn't work the same at all.
Yeah.
So that's all I have at this point in this project. We're now moving the installation work to his place in Vancouver.
Yeah. They all work perfectly in your head. It's when you actually build them that you start running into problems.
It'd be so much better if we could just sleep through it all, right? Where it always works in our dreams.
Well, I don't know. I've had some really good employment helping to solve some of those major project problems in the field.
Well, there is that too. Yeah.
Just like all football teams are perfect before the season starts and you start playing games.
For some reason, especially America's team. The Cowboys.
Well, I guess I got a little spin-off from Tom's thing, and that is I'm looking at a sensor, like the 9DOF sensors, and I know that a lot of people do the B&O 055, but there's a new one from Adafruit Spark Fun, which is B&O 085, which uses the same MEMS technology as a 55, but in the same processor, but a different company did the programming for the processor.
Yep.
And I was wondering if anyone has any thoughts about those two, because I'm going to buy some I2C, the quick stuff from Adafruit, and I figured I need to buy enough to make it worth my shipping costs. And
I came across.
So I was looking at the L85 versus the 55, and 55 is, I guess, safe because there's a lot of libraries and stuff. And I heard the 85, the libraries take a lot more horsepower. But I don't know about performance-wise from the two different programming code that's in the Cortex M0, because they both use Cortex M0, but they have different code inside of them to do all the fusion and stuff from all the sensors.
I just watched. So there's a guy I watch on YouTube that spins rockets up, and he does a lot with IMUs, and he's tested a bunch of them. I'll put a link to some of the results of his tests. It's a different application. I mean, he's more worried about high G than we are, obviously. But I came across that today. And he has some notes on some of those IMUs that might be helpful. Towards the bottom, he's got some that work really well for him, and some that don't. And it might the notes aren't great, but some of the notes on IG, obviously aren't applicable, but it might be helpful.
I thought Adafruit had something, as to why you'd want to get one or the other. It might be in the 85 description. I haven't looked at it in a long time, but I thought she, talked about that. It's obviously two different companies. It's similar hardware, but and I know, you can probably spend a long time trying to duplicate what they did. I don't know that any of us would really have that much time or interest or experience to be able to do better than what they've done. So yeah, if you can use either part, I think you're much better ahead than, using the individual sensors, and because there's an awful lot that goes into, Coleman filtering and
the particular.
I used a raw sensor on my last robot, and the code I threw together, it worked sort of. It drove a straight line. I won that contest, I guess, but
So
I wouldn't do much more than that.
So, Mike, your goal of having the IMU on a robot, is it basically for compass type information?
I think so. Yeah.
Okay.
Like to do the.
I happen to be using a very cheap one, the Honeywell 5883, and Ian is using the Chinese licensed version of the Honeywell compass, simply because Honeywell got out of the business, sold the intellectual property to a Chinese company, and the Chinese company, as it turns out, or the first Chinese company, as it turns out, actually built a better one. So Ian has a better version of the Honeywell 5883, and that's kind of fun. We actually had to find a driver that could automatically tell the difference, because he didn't want to have to figure out how to modify the library code. We're trying to make it the same. But in my research on tilt compensation, which gets you into the multiple degrees of freedom, because you need accelerometers to do tilt compensation, the BNO 055 comes up a lot, the Bosch unit. Because it's very popular and very well done. But it has one interesting complication, and that is it does auto tilt compensation. And apparently you can't turn it off. And the problem is that you could be driving along with a compass that you thought was working perfectly fine, and then the internal fusion processors decide it's time to auto recalibrate. So they auto recalibrate, and all of a sudden you're going in the wrong direction. You may not want that to happen. A lot of people are very frustrated by that in practical use.
I wonder if the 085, the different code that doesn't use the Bosch code would takes care of that. It says it has a lot more options than the Bosch.
Presumably they became aware of it and they would have improved that as they developed another one. But I just thought it was a very interesting comment. As I started to run into it a lot as I was doing research, because other than that, it's a well-respected IMU.
Yeah, seems to drift a little, but yeah.
So, Mike, I think it must have been a year or two, maybe 2 years ago, maybe a little more, but there's a guy, Murray, on for a while at the time from New Zealand, and he, I believe, did a comparison in hand of the 085 and the 055. I'm not sure the best way to search through the archives or the YouTubes to find it. If we have the chat listed somewhere.
I guess
085 maybe.
Yeah, searching for the 85 would probably show it up.
Yeah, you search for that.
Search on Murray Abrams or
Murray or 085. I could swear he looked at that. And as I remember from it, I don't know if there was chicken before the egg or what new or better, but I kind of recall that they had different design goals actually. That the firmware for the one was maybe designed for motion capture, like for actors, like you strap on your joints or something. And the other one was designed for something else. And I wonder if that has to do with this effect Tom has described, which I've seen on the 055, where the absolute measure of compass drifts if you do anything with the accelerometer. Or
Now, one of the things that I think it was last meeting or the meeting before, probably a couple meetings ago, I talked about this, and one of the things that I presented where a person had made some changes to the Adafruit library, which I believe have been encompassed in the newer version of the Adafruit library. And one of the strategies that he's suggesting, or one of these guys suggested, is that you periodically, otherwise you capture your calibration that you want. Okay, you calibrate your compass, and you have those constants stored, and you periodically renew them. Okay, so you're constantly returning the calibration back to what you originally had done. And so, I mean, there's a couple of strategies there to consider. And like I say, if you look back a couple, I think I showed you where he had the B&O on a little platform, and he was showing the compass as he moved it around. So and I believe that Carl is right. And another person who I believe used the 80, the B&O 85 was, I think, Chris Netter. So that might be another name that you might want to check on. Chris Netter and see when he popped up. And I don't know if you might just say IMU. I don't know if you would be able to talk about it, but again, all of our chat records are pretty much searchable by Google now.
Also, in the research I was doing, I ran into another chip that's intended for tilt compensated compasses. I've put the name of the module in the chat. Among others, Adafruit provides it, and they also provide a library of drivers intended specifically to produce a tilt compensated compass using that module. So I've ordered several of them to experiment with and see what they're like. They look very easy to use. That might also be another one that's worth looking at from a compass point of view.
Yeah, and Mike, I guess one last thing I'd feel a little not saying about this is the WIT Motion 901, WT 901 module, which you can buy off of Amazon for $30. It uses, an MP something 9050, I believe. And it's also got built-in Kalman filters through an M0. And Scott used it. He used a version of it. You can get, there's like 5 or 6 versions of it. Some of them have a little nice plastic case on them. Some of them are just kind of like a raw module. And he was using one that had a plastic case on it. And I'm been playing around and plan to use some of the ones that are just bare modules because I got them for a good price. And so anyway, that's another option that you might look at. I'll put a link to what I'm using. Well, I can't. And if you look at the videos, we have robot interviews from last Robo Columbus. In the robot video of Belch, it will show that sensor. Okay. So,
Pat, were you still looking at putting a compass on your robot?
I am looking at the compass on my outdoor robot. And the one I'm using is that GY 511 you have posted in the chat.
The 58. Yep.
Yeah, and the one basically in the inside the house, I was getting good luck with it. At least repeatability when I'm rotating it around and coming back. I haven't done a calibration on it. I've left it as a default calibration, but it's still much better than anything I have found so far.
Yeah, I'm pretty happy with my uses of the 5883, but it's only workbench stuff right now.
Yeah, so I did go through the documentation you gave me on doing a full calibration on how to set it up and how to do it. Yep. And it's something I'd like to do because I think it's fairly easy to just save those into memory and load them on startup and go from there.
Exactly. If you're happy, because I automatically store in double EEPROM once a calibration's done successfully. And if you're happy with the way that works, there's no reason to calibrate again because it'll automatically use what's saved in double EEPROM. But you really need to calibrate. If you don't calibrate at least once, you'll have really bad readings.
So yeah, and that's what surprised me is I haven't calibrated, and I'm actually getting decent values out of it right now.
That's really good to hear. So both Ian and I have had problems until we calibrated. It took me a while for him to get his system in Vancouver set up so that he understood how to do the calibration and had everything working. Once he did that, it was running beautifully for him as well.
You guys must just have magnetic personalities.
Well, I tried half a dozen of them before I could get one that actually gave me any sort of reading. And out of curiosity, I tried this GY 511, the 5883, I think it is. Yeah. And it's this one I hit on out of Amazon has been spectacular, actually.
Yeah. Now I've identified 4 different variations of the 5883 chip. I have the original Honeywell. Ian has one of the units preceded by QMC, but there are 2 others. They all work, but they have completely different internals. So you have to use different driver logic with them in order to make them talk. So just be aware if you're getting any more or playing with them. You have to know which one you've got. You got to get your magnifying glass out and read those little tiny letters on the IC.
Yeah, so the one I had was the LSM 303. And
okay. Yeah.
It's labeled as a GY 511. And it's been, like I say, phenomenal.
So you have an LSM 303?
303, yes.
All right, good. And you like it?
And I very much like it. Like I said, I tried several of the 5883s, and without a calibration, I wasn't getting anywhere at all.
Correct.
and I was having similar luck with the BNO 55, that I was not getting anything repeatable and it would tend to screw up.
Well, that's interesting. I ordered the 303s simply because I read so many good reviews about them. So yours is just another great review on that chip. Good.
Yeah. We're just a non-engineer, just electrician working on a chip and having very good luck with, repeatability, moving it around. And that was with it, fastened to the robot and just spinning it around on the turntable and until the wires get all tangled, but back and forth, back and forth, back and forth. And then when you turn it to, Cartesian angle, north or east or west, whatever, I was getting fairly close to it all the time.
That says good news. Thank you.
Yeah, it kind of makes me wonder the metal plates they put in, people with head injuries. I wonder if those are ferrous materials or say it only works when he's not next to it, Who knows what they make them out of, though? I don't know.
Stainless steel.
Probably, yeah.
Maybe titanium. Who knows?
Yeah.
I thought they're using UHMW now.
Oh, I don't know.
All right, guys, I think we're squarely in open mic night part of things. So that was a good segue there we just had. So anything else for tonight? What's on tap?
I've got a question. Actually, I got two for the group here.
Okay.
So I've built robots for quite some time, but what's new this time around is the ROS element. I just want to get a survey of what IDEs you guys are using. I'm kind of tending towards the VS Code IDE. So, okay, I see a couple of people shaking their head. That's the kind of the favorite because it does both C++ and Python.
Yeah.
I'm not doing it, but everybody I see using it is using VS Code. So that was what I was planning to do, but once again, I haven't done it. So
yeah,
personal experience. I haven't done it either, and it seems like VS Code is the thing to do.
I see a reference to why.
VS Code with Platform IO.
So yeah, I saw an extension or two that were you add to it to make it compatible with ROS. I've got it written down somewhere. Okay, well, so it sounds like that's the reason what I'll do. The other is just a question. The last robot I built, I started using behavioral programming AI in it. Okay, so is that what's pretty common for you guys too? I saw three heads shaking their heads yes on that.
Yeah.
No?
I think we've had one person present on behavioral programming, but we've had a longtime member who's not online tonight who's using a kind of earlier similar thing, subsumption architectures.
Yeah, right.
So we talk about subsumption a lot based on his experience, but like I said, we've only heard one presentation, I think. Is that right, Doug, on behavioral?
Oh, yeah, I was immediately thinking subsumption, which I think is considered a behavioral technique. And so there's several people who've used it, none to the degree that David Anderson has used. David Anderson has used it very extremely successfully. But almost if you think of it just from a paradigm of programming your robot, it does have the basic idea how you're going to have elements of behavioral. Let me see if I can find it. In fact, I was looking at this today. This is an old robotics exploration books for Legos, okay? And I was looking at it, and he's talking in here about control. And he's saying, you know, anyway, what I'm saying is when you finally get out, if you think of it, if you have a priority-driven state machine, you're using some form of assumption. Okay. And so I think a lot of people do that. And like for my outdoor task, it's very, very useful because, you know, the top level is real easy to define as if I see an obstacle or I detect an obstacle, that's going to take an obstacle task, the obstacle detection task. If everything is not tripped, you know, all of the other things aren't tripped, then the bottom level is go straight. So most robots, even though they may not call it that, have some form or have elements of it in their programming. So I don't know, but you know, if you're mobile, I think somebody here pulled out a couple of weeks ago a copy of Mobile Robotics. That one, yep. That book is a very good explanation of it for a hobbyist type person.
Yeah, I mean, I'm well versed in it. In fact, I was my last robot was an Arduino, and I physically ran out of memory.
Yeah.
until I came across this behavioral programming or subsumption.
Yeah.
And it made a world of difference, and I was surprised on how quick it could respond. It was just another query to the group here. What do you use? And it sounds like something similar.
Yeah. Now, there's a I don't know how you would find this. It was sometime 6 or 7 months ago. I told David I was going to do a task because I just wanted to see if I could do it. So I put my robot in my kitchen and I drove it to my front door foyer. Okay. So to do that, it had to go down some hallways and go through some rooms to get there. And I did it, but the technique I did it was more of a dead reckoning technique. And so David went through it on his robot, and his was in the halls of his workstation, halls of his workplace. And he used assumption. And one of the things that you really see is how smooth it is, how it just flows. It's like the robot looked over there, saw it, and just kept going. It's not, okay, I detected something and I'm turning, you know, I detected something, I'm turning. There you're looking at something out on this, it's almost kind of like it incorporates a kind of a wall following technique so that if you have obstacles, it just kind of flows around them. It's, so yeah, I know I'd hate to direct somebody to look up David Anderson and see which meetings he was at, and then see if you can look at the last couple of ones that come up, and that's really a good thing. I don't know.
There's also, I think, because he's mentioned that a few times, Doug, and why it behaves that way. And that's one of his trademarks is, right, he likes to just watch the different behaviors, the kind of emergent behavior in a way.
Yeah.
And when this was during the COVID times, when he was online really regularly, and he gave some really knock out of the park kind of presentations. Yeah. If you find the one in COVID 2021, 20 or so, plus or minus, there's one or two meetings when it was dedicated to David presenting his architecture. And he explained that there's a couple different ways, if I remember right, there's a couple different ways to implement the subsumption architecture. And he used the one where I think all of the different state, I'm using my own words now, but the things that measure the different sensors. They all function in every pass.
Yes.
And they all feed into his arbitrator. And based on any given time, this one might have precedence over that one,
yes,
might subsume the other one. And because they all feed in all the time, he said it has the effect that kind of gradually, like this one that says go straight, it starts to have an effect. And then this one that says no, turn left. So then as they're both feeding in, gradually the one that says turn left becomes the one that's having all of the input, and the other one's getting subsumed. And that's what makes it have such a nice, gradual, smooth. That plus he also, he incorporated like slew rate limiters. So he doesn't, and I think he lets his motor, let's see, the closest loop to the motor can drive pretty high rate, but the output command from his arbitrator in the subsumption is slew rate limited. So he only allows it to change by a certain amount in every cycle.
Yeah, so that's mine did something similar. Multiple times a second, every behavior is competing to be dominant.
Yes, yeah.
And depending on the environment, it would just go back and forth, and you would have this. You wouldn't jerk from one to the next. You would actually have a slewing, and that was actually a variable. If you liked it, you could change it, and it could transition faster or slower. Yeah.
But that book that you're reading there, his architecture is very similar to that implementation. Where it describes the augmented finite state machine approach to, and the arbiter and the behaviors in that
Talking
book.
about this one here?
Yeah, that one. Yeah. If you read through that, his approach is very similar to one that's outlined in that book.
Yeah, the question was, how common was this? I stumbled on this on my last robot, and it sounds like if you do this long enough, most people kind of gravitate to something similar, it looks like. So.
Yeah, mine is. I don't know about that, but
it was phenomenal. I was trying to do the if to then else statements, and I just ran out of memory, and I never could think of all the conditions, and then I found this, and it could fit in my Arduino, and it was just fantastic. The behavior, and it almost looked organic.
Yeah, there's actually in the DPRG library, there's a lot of his routines in there. The multitasker that his code's based on is in there, as are some of the other routines. And I think he's posted in multiple of his talks and multiple of his papers, not just that video. I think he's posted code snippets as well. That will kind of give you an idea. In the multitasker in his task structure, it kind of gives you an outline of how things work and how the arbiter, takes the output from those tasks. He divides his sensor reading up and the behavioral code into separate blocks of code. But if you read through that, then it'll kind of give you an idea of what he's doing. Not details on the speed slewing that I saw. Maybe it's in there. I just didn't see it.
I'd agree, Brad. His early work with large code snippets is just astonishingly easy to follow. I got a huge amount out of it once I understood how well his robots were working.
Yeah.
And it's Dave Anderson, you said?
Yeah.
Mm-hmm. Okay.
David P. Anderson.
P. Anderson.
You can get to the SMU.edu links. Those are pretty good.
Because he wrote and published those code snippets quite a while back, he was running on smaller 8-bit processors, and there's no code bloat there. There's not that much. There's an awful lot of incredibly good, concise code he's described, without a whole lot of garbage in it.
And that can be found on the DPRG website. Archives, you said archives?
Yes, some of it can, and there's links to, he's got a page on the SMU education website. So if you find smu.edu links for David P. Anderson, he's got a robot page where he kind of defines what he's doing, not in a lot of detail to get lost, but you can kind of get the gist of the architecture there.
Well, I just Googled D. Anderson robots and got 4 of his videos.
Yeah, good stuff.
Just D. Anderson robots.
I recommend starting with the seminar he gave to DPRG 12 years ago. I posted a link to that in the chat.
Okay.
What, the 2015 series?
It was longer ago than that, I think.
Yeah.
Well, he has one more recent than 12 years ago, I believe.
Yeah, but as far as comprehensive goes, I think that's the most comprehensive introduction he ever gave.
And he also, like I say, we really pinned David down sometime within the last 2 years and got to have him explain how his code is set up. So it is also, there's even more detail, what I'm saying, in one of these Robot Builders Night virtuals, but you have to find it. Maybe that might be something we can, if anybody finds it, maybe they can put it in a post next week.
Yeah, I think I've got a link to it, but it's on the other computer.
Yeah.
Yeah, when I did the D. Anderson robots, one of the ones that came up was from December 12 of 2011, which is, I don't know, hours long, 2 hours long, where it says David Anderson demonstrates his method for creating.
Yeah, that's the one that's on the link in the sidebar.
For creating autonomous robots. Which is very extensive. 2.5
That's the one I posted in the chat. Yeah.
Yeah. Is that the one you did?
Yeah.
Yeah.
I was there that day. It was very good.
Yep.
Oh, those are the only questions I had. That's it. I just wanted to query that group.
Yeah, that's a good one. Yep, that's the one.
That's cool. Thanks.
So I guess. Go ahead.
Here is the slide deck for one of his talks that he recently gave in, I think, 21. I'll put it in the group too.
Yeah.
So that's another one.
Yeah. Like that. So I guess where I am this week is I've ripped it. I'm kind of at the point where I need to actually get things on the robot. I mean, I've tested everything and got motors moving and my code compiled and the sensors all working, in bits and pieces on the bench top. But now I'm to the point where, the next things I need to do are actually kind of integrate everything. So that's what I've been doing over the last week. But it's been so long since I developed anything that a lot of my time is just spent relearning things like, the design system I used originally has changed a couple of times. And so trying to do things like design the bumper, I've got to go back and learn new tools first, So it's just kind of been a week of going back and learning stuff that I haven't touched in several years. So that's kind of where I am. I keep ordering parts and I keep watching the DPRG videos and getting project envy and wanting to go down different directions and not stay on task. So it's kind of been a struggle this week, just trying to make progress on my own project instead of starting 15 new ones. So that's kind of where I am. Oh, I did a very, very high-tech cardboard cutout modeling of where things need to go in my robot. You know, I took embroidery thread and made wire bundles for, you know, to kind of model connectors on how far the wires need to go and things like that. Because I couldn't get the 3D tool to work, so I just did cardboard cutouts for a while. But other than that, I haven't made. Nothing's moving still, so maybe next week.
One of my students is making parts of a robot out of crochet.
It's good for, you know, if you're trying to do quick connectors or those stemma connectors and you're trying to figure out how long your cables need to be, it's kind of the perfect solution, really. You just take embroidery thread and it comes in the colors you need. You just get 4 or 5 conductors, tie a knot in it and see how far it needs to be, and then cut the cables that long. It's kind of stupid easy, you know.
Oh, cool. All right. So where are we? Anyone else have some good topics for tonight? Well, hearing that, I suggest we call it a night and wish each other a good weekend of building and researching. And don't forget, there was a gold star, Doug. We had a gold star tonight.
Yeah.
So,
well, hey, I'll mention one more thing that might be worthwhile. A few of you may know Bob Cook from the Vancouver Robotics Club. Bob entered the Robo Magellan contest at the Seattle Robotics Society last month with his rather interesting machine learning video-based autonomous navigation. He's giving the paper that he wrote on how he did all of that work, the machine learning work, at the Seattle Robotics meeting this coming weekend. If you're familiar with it, you can see it on their website. I'm not sure what time it is. It's on Saturday, I think. So he's giving his presentation virtually at that meeting on Saturday. I attended it when he gave it to the Vancouver Club. Very, very interesting presentation if you're inclined to go in that direction, the video machine learning stuff. He's got a nice implementation, and I'm sure his next version, based on a Nano Jetson, will be even better. It'll run in real time.
Is that the Orpheus robot?
No, that's not what he called it.
Okay, different one.
Yeah. Basically, he did a huge amount of work developing a 400 or 500 sample video image library that allowed him to train a machine learning implementation in how to recognize an orange cone under various background conditions and various distances. And once he had programmed or trained that machine learning autonomous tool, then he implemented that on a Raspberry Pi and ran it in real time in the field, basically collecting data from the video camera in real time, processing the information according to the executable version of the machine learning exercise in order to allow it to figure out where cones were and then steer his robot towards them. Extremely interesting process he went through to do that. If you're inclined to do machine learning.
Yeah.
Complicated stuff. I've done some work in it myself.
Birdie is the robot, it looks like.
But Bob's a good presenter as well, so it's quite entertaining as well.
So that's interesting. Yeah, I'm interested in that. Thank you for that.
Okay. Seattle Robotics Club on Saturday.
Hey, as far as the next contest goes, DPRG normally holds contests in May and November. Is that correct?
Yeah, typically spring and fall. Yeah, indoor in spring and outdoor in fall.
And sometimes we have an indoor in the fall too, depending on what people want to do. But at least an indoor in spring and an outdoor in fall. But that doesn't mean you can't ever come down and slap, say, challenge you guys. And, I mean, that's all, we'd be
all
willing.
it takes sometimes.
Yeah, that's all it needs for us to set something up.
Well, I got to get something finished first, but I'm interested in that May one. And that would be held at where in Dallas?
It's on I-35, off of I-35 on what's the name of that road that goes crosswards there? Valwood Parkway. It's right around in that area.
It's the Dallas Makerspace. Yeah.
It's the Dallas Makerspace. You can go to their website and find the exact direct. You can find it by going to the DPRG website.
Yeah.
On the homepage, there's a map to it.
Okay. And I think I can do that in person, but you also do the virtual stuff still?
Yeah, we do allow that. And because anybody who's not here, that's... Yeah, you fall in a different pile. The people that show up for the person-to-person one, they're one prize pile, and the virtual people are different prize pile. But other than that, we encourage. We don't want local people doing it virtual if they can attend, because we want to meet everybody, and So, by the way, I did get one thing. Steve Edwards, anybody who attended Robo Columbus, we think we know who owns this, but we're not sure. Somebody left a laptop up at Steve's house. So if you're missing a laptop, that might be yours. But we think we know whose it is, and we've contacted him separately. But...
we'll know if you can log into it, if it's yours.
Yeah. So
it's not ticking, is it, Doug?
Yeah.
Okay.
But let's see what else. Yeah. So anyway, that's now the club. Probably in January, we'll decide on what contests we'll want to run. We'll probably run something very similar to what we had last time. If people have reached the point where they feel comfortable running 6 cans, there's other contests that we can run that they might like. For example, the person who mentioned machine learning, we have run donkey car contests, and we can set that up. If somebody has a donkey car and wants to evaluate it, we can run that in our room. See, we also have a contest that was proposed but never run, where it's a search problem, where you start in a square, basically a small square, and that's your landing point. And a set of different objects are placed in the room. And depending on, initially, depending if we've got people who are just learning and trying to advance, they'd probably be pretty easy and you can see them all. And then the robot has to find them, go to them, pick them up, bring them back to the square. Okay. So, the ideal place would be you'd see them and then map himself a path that would minimize the distance he had to travel to bring them all back and have some sort of scoop. But that would be the perfect robot, but most of us would probably just run out, grab it, and bring it back. So and the intent was that as people got that and did that very easily, then finding the objects, they would not be visible in the square. You'd have to be somewhere you'd have to be close to see them. But that one's never been run, but we would love to run it if somebody wants to try it.
That's the sample retrieval contest? I
think that's what it's called.
Okay.
And there's some other options out there too that have been not retired, but interest isn't there. For example, we haven't had anybody run line following in a long time. We have three levels, I think. Yeah. What we call beginner or novice, which is pretty simple, but if you haven't done a line following robot, it's a good one to start. Then we have advanced, which has things like 90-degree turns, gaps, segmented S-curves, and some weird stuff, basically. And then we have challenge, which is nobody's actually solved it on the floor. We've had some people go through it with multiple stops. But
and too long time, but
yeah. And the problem with it, well, not the problem, but one of the things is your robot has to think a little bit heavier because an algorithm that will work on one square won't necessarily work on another square. So it challenge would be if anybody wants to run that, we've got that course all easy to set up and put out there and give it a shot.
I do have a question on. I think when I read the four corner, the text makes it sound like you can be dropped in any one of the squares randomly. That there's no definitive initial starting point.
That's correct. And and if you think about it for a while, there's actually kind of an optimum starting point. You can run your robot in either direction. You can start it anywhere. But wherever you start, that's where we mark where you got to come back to.
Right. Okay.
Okay.
The question is, are the judges putting you down anywhere, or is
you put down your robot where you want to start? You decide where you want to start. Okay. And
okay, is that also true for the 5-spot or
5-spot
or the
5-spot?
5-spot was meant to be original. That's where you have to visit each corner of the room and I think a spot in the center. And the intent of that was, I believe, was to try to have a form of line following. But it wasn't all line following because you have to find the spot in the center of the room, you know what I mean? Which has no walls. So that one was not a very popular contest. Getting into the corners seemed to be a problem for people.
It would seem like you could do the 4 corners with just wall following, but the 5...
No. 4 corners, if I remember right, 4 corners, you have 4... You've got a square marked out. Right. We usually use small cones, but they don't. The rule says you can't expect on those cones to be used. It could be anything could be used. It could be a coin on the floor or a tape mark. You know what I mean? And you have to drive around the square and come back.
Okay.
To exactly where you are.
Right. Okay.
That's a kind of a traditional contest. I mean that's and another one we haven't done in a long time that was really cool is tabletop. And tabletop the traditional tabletop was you're set on a sort of like a cafeteria table, and you had to go to the end of the table, stick over a little bit, and come back. Okay? Then you had to knock a can off of the table. Okay? And then the third one was you had to push a can into a box that overhung the table. So that was the traditional tabletop, and that actually originated, I believe, by the Homemade Robots Club. That was I want to say it was in Seattle, but it might have been Portland. Probably was Portland. And then it was used by several clubs. Now we have something called Big Tabletop or something or other, and it's a little different. It has a starting box that's defined in one corner. And I don't have at least 5 cans on the table. Okay? So I can't remember it, but I think there's 5 on there. And you have to push all 5 cans. No, it might even be more. I think okay, let's just say you have 5 cans. Well, no, say 6 cans. So you'd have to take 3 of those cans and push them into a box, into a overhanging box. So you'd have to find the can, push it into the overhanging box. Then you had to take the 3 remaining cans and line them up so that a yardstick could be placed on top of them and touch all 3 cans. Okay? And then I believe that I think one of the cans of the line of cans has to be in the starting square, if I remember right.
You have to go to the grocery.
Oh, wait a minute. No, wait a minute.
Buy the cans too.
No. Let me put this back. I think it was, okay, you had to take, yeah, I think it was 5. So you had 5 cans sitting out on the field. One of them you had to push into a box. One you just had to push off the edge. And one you had to return to the starting point. So now you had 5, so you have 2 leftover cans, okay? Well, now you had to line those cans up with the can that's in the starting box so that you could put a yard ruler on top.
Oh my God, that sounds kind of difficult.
You know, we ran it successfully, you know, and we had a gentleman from Vancouver, I think, who aced it too. He really did a good job. And Ron, God, what was Ron's last name? Anyway, Ron also did it.
Ron Grant.
Ron Grant did it very successfully, and I've done it successfully. And I think there was 1 or 2 other people, but it was a fun contest because if your robot, there's a certain, what is it, pashah? I don't know what's the word, where you have to sit there calmly at the starting box and watch your robot go all the way over across there, and it's built on a 4x4 table.
Right.
So if your guy goes over there and your robot goes a little too close to the edge, poof, over the side. So it takes a little, we've had guys running around trying to catch it, but it doesn't make you look cool.
Well, that's cool. Okay.
Yeah. Okay.
Well, I'll be interested to hear what the contests are.
Yeah, well, think about it if you want. If there's one you're interested in, and you're willing to build for it, we'll run it.
I've just got to focus on the one, right? Right. Yeah.
Well, they're supposed. The reason why our contests are so they're done the way they are is to help people on their progress of building robots. Like the quickest one is to go straight out, turn around, go straight out, and come back.
Right.
That's the easiest one. And a person still needs to know how to mark a distance, drive a distance, and drive in a straight line.
Right. There's got to be a lot working before you can do even that. And
yeah, that's right. Exactly. And line following, you don't need a lot of that sort of stuff because your control is actually following the line. It's not following, you're not following your direction. You're not really following your speed, though there is speed, obviously speed. So line following is another, if you can't drive in a straight line, you can still do line following, or at least the beginning one.
Yep.
Yeah.
Okay. Well, I might be in Dallas, but I may not be all there, but I'm not all here either. So
anyway, those are some of the. They're fun to talk about.
Cool. Well, thank you guys again for being such a resource. I've learned so much over the last week just watching DPRG videos. Really appreciate it.
Welcome aboard. Feel free to chime in with questions and show and tell.
Inane comments from the peanut gallery. That's my motive.
There you go.
Operation.
we live on that. All right, guys. Contest. Any other topics for tonight? Alrighty.
Good night.
Stop the recording. Wish you all a good